Welcome, everyone. Today, we're going to break down a real GCSE Physics exam question, piece by piece, to figure out exactly how to score every single mock. Okay, let's dive right in. We're looking at question 05 from an AQA paper, and it's all about energy, power, and solar cells. We're going to master this together, using the official mark scheme to see exactly what the examiners are looking for. Think of this like we're peeking behind the curtain. We're going to get inside the mind of the examiner and see what really makes them tick. Because it's not just about getting the right answer, it's about presenting it in the perfect way to get all the credit. So here's our game plan. We'll kick things off with the energy calculation. Then we'll move on to the current calculation. After that, we'll tackle the power calculation and then the written explanation. And to wrap it all up, we'll have a guide with all the key takeaways for getting full marks. Okay, first up, let's get into our first section, the energy calculation. This one's all about mean energy transfer. So let's look at what they're giving us. We've got the total energy for a whole year and the number of seconds in a year. The mission is pretty clear. Find the energy per second. But, and this is super important, they've specified 3 significant figures. That's a classic exam instruction you can't ignore. The process is really straightforward. You're just going to plug the numbers into the formula, do the calculation, and then round it off. But here's a pro tip. Always write down your substitution. It's such an easy way to pick up a mark, even if your final calculation is a tiny bit off. And look at this. This is how the marks are given out. You get 1 whole mark just for writing down that first line, just for showing you know which numbers go where. The second mark, that's for the final, correctly rounded answer. See? Showing your work literally pays off. All right, moving on to our second part, the current calculation. Now, this one's a 4-marker, which means there's a bit more to it and, well, more opportunities to show what you know. Okay. Let's break this one down. We've got charge flow in coulombs, a time period in hours, and we need to find the current in amps. The second you see mismatched units like that, hours instead of seconds, a little alarm bell should be ringing in your head. A unit conversion is definitely on the cards here. So there are a few steps to this dance, and that first one, the unit conversion, is absolutely non-negotiable. Let's see how the mark scheme actually rewards you for getting each part of this rate. Now, this is a perfect example of why you show every single step. Just look at it. Each line of your working out gets you a mark. 1 for the time conversion, 1 for putting the numbers in the formula, 1 for rearranging it, and 1 for the final answer. Laying out your work clearly like this is how you guarantee you don't leave any marks on the table. And here's a little insider tip, straight from the mark scheme itself. It shows there's a bit of wiggle room. So even if you rounded your answer to 0.31 or 0.313, you would still get that final mark. It's good to know there's some flexibility there. Okay, on to our third section, the power calculation. This one's all about efficiency and power output, a real classic topic in physics exams. And right away, what's the first thing you should notice? Yep, the units. The input power is in kilowatts, or kW, but you can bet the answer needs to be in plain old watts, or W. It's a classic trap, but you're not going to fall for it. Now check out how the marks are split here. You get a whopping 2 marks for that first line of working alone, and that includes doing the unit conversion from kilowatts to W. That is huge. It means you've already banked 2/3 of the marks before you even touch your calculator for the final step. The last mark is for that final number. This is a really important note from the examiner. The answer they want to see is 1170W. They'll accept 1200, but only if your working out clearly shows that you rounded your numbers at some point. It's just another reason why showing your steps is absolutely essential. All right, let's switch gears a bit. Time to put the calculators down for our fourth and final part, the written explanation. These questions are all about communicating what you know in clear language. So this is a classic explain why question. And the most important thing you should see on the screen right now is that it's worth 2 marks. That number is basically a command from the examiner. It's telling you, I need 2 distinct, valid points from you. Not 1 long point, but 2 separate ideas. So how do you actually get those 2 marks? Well, here are the 2 scoring points, straight from the mark scheme. First, you'd say that a really large area of land would need to be covered with solar cells. Boom, that's 1 mark. Then, for the second mark, you explain why. Due to the low useful power output of the solar cells. See? 2 links, but separate points. That's how you get 2 marks. And let's just focus on that first point for a second. Notice how simple and direct the wording is. You don't need to write an essay. A single, clear, concise sentence that gets right to the point is all you need to bag the mark. So we've pulled that entire question apart. What are the big lessons here? Let's boil it all down into a final guide to getting full marks that you can use on any question. Okay, these are the golden rules. Seriously, they don't just apply to this one question. They apply to your entire physics paper. Always check your units. Show every single line of your work. For explain questions, give 1 point for every mark available. And read the question for those little details, like 3 significant figures. This is your toolkit for maximizing your score. And that's our deep dive into question 5. I'll leave you with a final thought to take with you into your revision. By understanding how the examiner thinks, you're not just answering questions anymore. You're giving them exactly what they're looking for. Thanks for watching.